Thank you, Richard, and thanks to the AIG for giving me the opportunity to speak to you this afternoon. My presentation is about 20-25 minutes. I do present a great deal of information. I won't necessarily be able to cover every slide in detail, but if you wish to have a copy, there will be a copy available on PDF. The rare earths industry has undergone a great change in the last 6 to 12 months. A couple of years ago, I was really in a position where I was saying to people, well, illegal mining in China is out of control, and as a result, prices are very low, so there's not much point in anybody trying to raise money for a rare earth project in the rest of the world or outside China. So we've now seen quite a change in that in the last 6 to 12 months, and that's what this presentation will reflect. So there's a disclaimer. That's a disclosure. Right, I'll talk about the rare earths industry today, forecast demand and supply balance, which is always an issue, China in particular, what to look for in a rare earth project. Because the situation's changed, I thought I would just run through very quickly the sort of criteria that I believe are important for a successful project, which might help you as geologists in your first look at a project. And then as a result of that, I'll end up with identifying what I see as the opportunity between now and 2025. The rare earths industry over the past 50 years has grown by a factor of 15. There's very few commodities would that be in the position. When I first started working in the lithium industry in 1985, they've still got a long way to go to match that in 2035. So that's outstanding growth. That's a reflection of the many uses of rare earths across the many rare earths that make up the rare earths mix. That's a graph of recent supply and demand. Overall, supply and demand has grown by about 8% per annum. It's driven by the demand for rare earth magnets, primarily neodymium and praseodymium, and to a certain extent dysprosium. China has had production quotas in place, which has led to the large amount of illegal mining, and I will cover that in some detail later. So the rare earths market today, global demand is probably about 170 to 180,000 tons of rare earth oxide. Those of you not familiar with the rare earths industry, we always talk in terms of rare earth oxide. Even if you're producing a cerium carbonate for the autocatalyst industry, it will be sold in terms of rare earth oxide contained and in terms of US dollars per kilo of REO. So that's the terminology that's used throughout here in this presentation. The global value of the rare earths industry today is about $4 to $5 billion. 12 months ago, it was only about $3.5 billion, and that increase is a reflection of the price increases of rare earths over the past, in particular, 6 to 12 months. China is dominant, supplies about 85-90% of global demand, and consumes about 70% of global demand. So I've said the demand for rare earths as a whole is driven by the demand for use in magnets. Now, for those of you not familiar with it, a rare earth magnet that contains neodymium and praseodymium is a very powerful magnet, many times more powerful than a ferrite magnet. If you have a powerful magnet, that enables you to have a very small electric motor. So originally, the Sunny Walkman would not have been possible without rare earth magnets, or as they're referred to here and elsewhere, often REPMs, rare earth permanent magnets. They are the preferred source they are preferred drive with a rare earth permanent magnet for electric vehicles and hybrid vehicles. And that is what is going to drive the demand for rare earths over the next few years. Nevertheless, the price, there is an element of price. If the price increases too much, there are alternatives, and I'll come back to that later. Lynas is the largest producer of rare earths outside China, had been struggling, but over the last 12 to 18 months, in keeping with those changes that we've seen, that's now become a very robust operation generating generating cash. There's still a very significant capital investment required originally to put a project in place that has the nameplate capacity to supply about 25,000 tonnes of rare earths a year. Last year it produced about 16,000 tonnes. It'll probably get close to its design capacity of 20,000 tonnes this year, which is just about 10% of global demand. So it's not, that shows you the dominance of China. There are several non-Chinese projects now being evaluated, and at last China does seem to be addressing the issue of illegal production. That's global demand I estimate global demand in 2017, and it'll be about 174,000 tonnes. Draw your attention to magnets. That's about 55 to 60,000 tonnes, and that's praseodymium and neodymium and dysprosium primarily. A little bit of terbium that also improves the retention of magnetic properties, elevating temperatures, as does dysprosium. Metal alloys, that actually is
Sorry, can you speak up a bit, please?
To move towards the microphone.
Well, okay, I'll speak up. Because I can't, from there, I can't shine this one there. Metal alloys is the application that includes batteries, and that's lanthanum nickel hydride battery. The Prius today still contains the lanthanum nickel hydride battery, and in all probability, we're going to see that continue for a while, but with the increasing demand and increasing improvement of lithium batteries, I believe probably in another 3 or 4 years, we're going to see demand for rare earths in batteries leveling off, but it's not going to happen immediately. Bearing in mind that when you introduce a new vehicle, they generally have a 7-year platform. So if you're going to supply, whether it's a lithium battery or a magnet for a drive or a magnet in the steering mechanism in a vehicle, rare earth magnet, that model will retain for 7 years. So there are changes, but in the automotive industry, which is driving the whole thing, they're not as rapid as many people seem to think. Nevertheless, they are happening. We do have a surplus of cerium in the rare earth, and the major applications for cerium are in glass and polishing and also in auto catalysts. With a huge surplus of the other rare earths, with the exception of neodymium and praseodymium, there is a surplus of cerium and lanthanum. So I think there will be a push to develop new applications for lanthanum and cerium, and we will see a greater use of lanthanum and cerium by the glass industry. One of the original uses for cerium started working in the industry was spectacles contained cerium because it reduces the transmission of ultraviolet light through the glass. I believe that that's an application that could be looked at again with a large surplus of cerium, perhaps in architectural glass. And in polishing powders, they're used in polishing powders as well. Nobody quite understands why, but if you use cerium in polishing powder to polish the surface of your mobile phone or your tablet, it's a combination of a mechanical action and a chemical action, and that's what gives a very high quality finish to your screen. So that's an increasing application. It's growing fairly rapidly at the moment, but can't grow fast enough because we've still got a large surplus of cerium. Those are the forecast rates of growth that I foresee up through to 2020. I think growth in demand for magnets is probably going to be about 8 to 15%. Probably closer to 15% in gross terms, but as we improve our recycling, the actual growth in demand is probably going to be something of the order of 10 to 11% per annum. The only other thing I'd say is that overall, the demand is going to increase at the bottom there. Compound growth is going to be about 8% per annum for the next few years. That's global demand in 2020. All I'd point out there is that we can see that demand by the magnet sector has grown from about 55 to 60,000 tonnes to 80,000 tonnes, and is now getting closer to 40% of global, of the total demand for rare earths. Overall, demand will be about 220,000 tonnes per annum. China will remain dominant, but at that time consuming about 71%, and I believe will still be supplying about maybe closer to 85, 86% than the current 90%, if one or two of the projects that we see in the wings are able to come on stream. Now, when the rare earth industry meets, one of the issues that is always discussed is what's called the issue of balance. Now, the 17 rare earths, and the ratio in which they occur in the ground never matches the ratio in which they're consumed. So at any one time, there are some rare earths that are in demand, and that is growing, that is resulting in pushing the overall demand for rare earths, and there are other rare earths for which there's a surplus. And quite clearly, you can see from the next slide that the demand is driven by the demand for praseodymium and neodymium, and they're roughly in balance. There's a little bit of a surplus because the legal miners are able to get away with illegal production, and they produce material at very low cost. But nevertheless, that's many people will show that praseodymium, neodymium, the supply is less than demand. If you take out the illegal production, that's correct. If you consider the production quotas in China, the actual supply would be about 50% of total demand. And that is the problem which I'll return to later. That you can see there is a huge surplus of cerium, which I mentioned before, and there's a large surplus of lanthanum. The current major uses for lanthanum are in petroleum cracking catalysts, and also in they increase the refractive index of glass, so they're used in a lot of the wide-angle lens in mobile phones and tablets as well. But that's not growing as quickly as we'd like, so there's lots of opportunities for scientists to find new applications. Now, China has been very successful in growing its rare earths industry, and it's well known in the 1970s that Deng Xiaoping said the Middle East has oil and China has rare earths. And they have they think in a very much longer term than we do. And we can see from this, over the last 40 to 50 years, in the 1970s they commenced producing rare earth mineral concentrates, which they exported. In the 1960s and 1980s they commenced producing rare earth chemical concentrates. A lot of the Japanese producers at that time transferred their plants and technology to China in exchange for buying the separated rare earths from them. In the 1990s, they went into producing separated rare earth oxides, and then now China goes all the way to producing the end product. Driving the current 5-year plan in China and the 5-year plan next year is something that Chinese call Made in China in 2025. And I would refer you to an excellent report that's been written by the EU, the Commission, the European Commission, which has identified this and the impact that this will have. One of their objectives, for instance, is that 50% of the rare earths that they mine in China, they will take them through to the ultimate product to sell. In other words, the vehicle or the television or the petroleum cracking catalyst, whatever. At the moment, that's only about 25% of the rare earths that they produce. This is the net result. Over the last few years, what we've seen is China is progressively moving downstream, and as that happens, more and more of the jobs, more and more of the revenue that's generated from the manufacture and value add of rare earths is going overseas. This is now something we've been talking about, a number of us, for a few years, but this is starting to be a matter of concern, particularly for Europe and North America. They don't want to see the continued migration of jobs, manufacturing jobs, into China. They've been very successful, and it's not going to be easy to do that, but we do. If we want to retain more jobs, we're going to have to do more of the value add. And the example that the lithium industry is setting here and going downstream to produce lithium chemicals is a good example to follow. This table, and if you want to look at it later, you can if you want to copy. This table demonstrates the impact of the demand for rare earth permanent magnets. In China, they do publish data about the volume of rare earth permanent magnets that they produce, consume, and they themselves, Dr. Chen, who's Vice President of the Chinese Rare Earth Society, and also Technical Director of the Association of Chinese Rare Earth Industry. He's produced figures which this table is based on. And he drew attention to this fact 3 or 4 years ago that China, the illegal production in China to meet demand will have to be about 30% of the additional 30% of the quota. This has increased steadily. Production quotas in China have not increased since 2014. China's now talking about increasing them, but as a result, even though the demand for rare earth permanent magnets has increased, the only way that demand can be met is through illegal production. That's what the impact is. And these are not my figures. These are figures produced by academics in China. The illegal producers have little regard for the environment, and there have been a number of studies carried out to estimate how much it will cost to rehabilitate the devastation caused by this lack of respect for the environment in the mines, tailings ponds, and production facilities that have been closed down. The estimated cost is about $30 to $40 billion US. Bearing in mind the estimated value of the rare earths industry in China last year was about $3 to $4 billion. In other words, if China decided tomorrow, which it could do being China, that it wanted to rehabilitate those operations over the next 10 years and the industry would pay for it, prices would have to double from what they were. Now, they haven't doubled since last year, but they've certainly increased by about 50 to 60%. And that is what is driving the industry at the moment. It's not only a question of price, it's also a question of the sustainability of the operations, and I'll return to that later. China has decided a few years ago that it would entrust the development of the rare earths industry to 6 state-owned enterprises. And they've been able to do that fairly successfully, and now they actually have control of the industry. They're starting to make big efforts to reduce the illegal mining activity. But you can see here that 2014 to 2016, the industry lost money. And that was because they weren't addressing that issue of illegal mining, and the illegal miners were selling at any price to make a sale, and they didn't respect the environment. Caused huge problems, as you can see from that former slide about the cost of rehabilitating those operations. So up until maybe the middle of last year, China, they had a strong commitment to developing new applications, financial support for loss-making companies, Any major company, particularly those which were owned by a state-owned enterprise, would get funded by the government if they made a loss and they're in difficulty. Production quotas in 2014, they increased, but in 15, 16, and 17, they've not increased, even though demand in China, by their own estimation, is growing at about 10 or 11% per annum, compared with the rest of the world, which is probably about 5 or 6% for an overall growth rate of about 6%. The capacity in China to produce rare earths, to produce separated rare earth oxides, is about 300,000 tons. But the production quota is only 105,000 tons. So there's a huge amount of potential capacity overhanging the industry in China. And we need to be aware of that. I think a lot of it is being closed down, but nevertheless, there's a lot of surplus idle capacity in China. As a result of a World Trade Organization ruling, China eliminated quotas and taxes, which reduced prices in 2015-16. The intent was to introduce some royalties to replace that, which would then pay for this rehabilitation. Negotiations between the government and industry are still going on, so they don't have those royalties. At some stage, they will be introduced, and that will certainly increase prices of the rare earths in China. As I've said many times, there was only minimal commitment to reducing illegal production until fairly recently. The industry consolidation and vertical integration of the industry, so it's virtually controlled by 6 state-owned enterprises, has been almost complete now. As a result of that, when those companies took over the other companies during the consolidation, the first thing they did was go in and seize all the assets of the company they were taking over. And they inevitably found there were larger stocks of rare earths than they thought were there. So over the last 2 or 3 years, we've had huge stocks from these illegal operations or other operations that were closed down, and that impacted on supply and demand and kept the prices down. Those stocks, I believe, have now been virtually exhausted and sold off, so that's another reason that we're seeing increases in prices. So what's China doing today, which is different? I've mentioned the idea of Made in China 2025. As I've said, I suggest if you're interested, you refer to the document produced by the EU, which talks about the impact on jobs and that sort of thing if China is successful in implementing this policy. They've talked about introducing production quotas to 140,000 tons by 2020. I don't believe that's enough. It doesn't fit with their predictions of future demand, which is difficult to understand. Sorry, I'm just going on. Just going on to the global situation in the rare earths industry today. I thought this was a slide ahead. We talked about the goal, Made in China 2025. I've talked about rehabilitation, the huge cost of that, the impact that can have on prices. The consolidation of the industry is virtually complete, and so the industry is now controlled by 6 state-owned enterprises, which enables the Chinese government to control the industry more closely. Today, in order to meet that demand for rare earths in China and taking the typical recoveries into consideration, they're mining about 300,000 to 400,000 tons of rare earths a year. Could well be more than that. A lot of these, effectively more than that. A lot of these illegal operations, because they were fly-by-night, they would go into the best deposits and they would high-grade them. So they probably sterilized a lot of resources. So China is now realizing that as a result of their inaction in trying to control the industry properly, many of their better resources are close to being exhausted. And that's why we see today there's a lot of interest by Chinese companies in major rare earth projects outside China. And I believe that's going to continue. China, as you'll recall from an earlier slide, has a separation capacity of about 300,000 tons a year. there are three steps in the mining production of rare earths. The first step is mining and producing a mineral concentrate. The second step is to produce a mixed rare earth carbonate or chloride, which contains most of the rare earths. And the final step is to separate the rare earths by solvent extraction. That's a very expensive process, requires very high capital costs. But because the margins are big, in the past there's been a huge investment in the separation capacity, so much so that the capacity is about 300,000 tons a year. So those Chinese companies that are investing in projects in the rest of the world are probably going to invest in them. They will produce a mineral concentrate, they will produce a mixed rare earth carbonate or chloride. The radioactive waste will be disposed of in the country of origin of the mine, and then in all probability they will export the rare earth carbonate chloride to China for separation. So China will still essentially control the rare earth industry. So there has to be a commitment to go further downstream where possible than just going to a mixed rare earth chemical concentrate. China approached the International Standards Organization a couple of years ago to establish some rare earth standards, and now that is underway. China is providing the secretariat. That is a great opportunity for the rest of the world to have an influence on that. China is only, providing the secretariat, it's only one member on that committee, and I'm working along with the people in the ISO on that. It will certainly help the rest of the world in terms of purchasing rare earths, because we're going to standardize packaging and the information that's provided on packaging and the way that products are advertised and meet international specifications. It's going to take a while, but we will have some international standards which, I say, will help level the playing field. The rest of the world, I've talked about the concern about made in China. We've heard many references today, and we read it in the media every day, that there's a big drive to convince many more people to produce hybrid vehicles and electric vehicles. Rare earths have a key role to play in driving in the production of those vehicles. Primarily, it's in the use of the rare earth permanent magnets. Up until about the beginning of this year, the price for neodymium was about $40 to $45 a kilo. It's increased to about $60. Well, it's been up to $80. It's back to about $60 to $70 a kilo today. The rare earth permanent magnet producers tell me that if the price of the magnet goes up to, the price of the oxide goes up to 85, 90, then they're going to look at alternatives. Now, basically, what that says is, if you have an operation and you want to produce rare earths, you've got to be able to produce, got to have an operation that's profitable at a rare earth price, probably at no more than $80 a kilo, to be sure. So, as I've said, on the other note, Chinese companies are showing a great interest in investing in overseas rare earth projects. The number of countries that are actually participating in the development of international standards is now China plus 8. When it was first introduced, there was some reluctance to participate, and there was only China plus 4. Now it's China plus 8. So there's a growing momentum for more people who wish to participate in the development of those standards, which I do believe will assist in leveling the playing field. We've got a number of issues to face in the rare earths industry. I've talked about how we need to address illegal production, the imbalance between demand and supply. There's got to be some more liaison on the impact of new technologies. How can we make more efficient use of the magnets? We have come great strides in improving the efficiency of the magnets. When rare earth magnets were first used in CD drives, it was about the size of the magnet was about 30 to 40 grams. A CD drive today has only got about 8 to 10 grams of rare earths in it. What's led to a lot of destruction in China is the development of the LED. A fluorescent light, which is about 1 meter long, contains about 1 gram of rare earths. An LED only contains about 10% of the rare earths that a fluorescent light does to generate the same amount of light. So we've seen a big change around in the heavy rare earths industry. Now that's the negative, but on the other side, we do know from that table that I showed up there that there's a lot of other rare earths in which there is now a surplus, including those heavy rare earths that are used in lighting. That's europium and yttrium and terbium primarily. But we do have to look at developing applications for those rare earths in which we have a surplus to assist in keeping the prices of those rare earths which are in greater demand down by generating greater gross revenue. So at the beginning I said, well, I'd finish up with some comments on what you might look for in a rare earth project when you first come across it. The grade and composition of the ore are very important, and something I think is often overrated is what many people call the basket price, where they take the rare earths as they occur in the ore body and put a value on each of those rare earths and say, well, if we separate those, a kilogram of those rare earths in that ratio, what's the value? It's indicative, it is very helpful, but very, very careful how you use it. Mineralogy is something I think is often overlooked. There have only been 4 minerals that have been commercially commercially processed and developed for the production of rare earths to date, with the possible exception of loperite in Russia, but that's subsidized by the aluminium that they produce. To develop a new process will take 10 or 11 years of pilot plant work, and I won't steal Ian Chambers' thunder, but he will explain that to you. Even Linus, when they started up at Mount Weld, when I first started working on the project in 1990, we had a resource and we had monazite, which has been processed for over 50 or 60 years. It was 15 years before they had finalized their process, and they didn't actually produce their first separated rare earth oxides until 2014, 2015. In other words, 25 years. And that's from a mineral that was being known to be a source of rare earths. So don't underestimate the cost of developing a process, particularly if it's a mineral that hasn't been used in the production of rare earths before. The pilot plant is key to that. As we all know, in many of these specialty metals, the only way you can get funding for the project is to have letters of intent or contracts in place to supply for the customers that you're going to supply with what you produce. And that's why you need a pilot plant. You need a pilot plant to produce samples for your potential customers to evaluate, so they're prepared to enter into a contract of supply with you. And it's not producing quantities in 10, 15 grams, it's producing it in 10 kilogram lots, demonstrating that you can fully produce what they need. That pilot plant is also fundamental in providing data for your definitive feasibility study to come up with the operating and capital costs, and also for demonstrating to the EPA and local communities that the process you propose to adopt can handle the waste adequately and meet local requirements for waste disposal. Radioactivity environmental management is an issue and has to be thought about. You've got to be cognizant of the local authorities and state requirements for that. Construction and startup. There's a lot of optimism associated with many projects in construction and startup. There were 2 projects that started up about 4 or 5 years ago outside the Western world, outside China, Linus and Molycorp. Both took twice the time to build the plant that they'd originally scheduled, and both took twice the time they originally scheduled to start the project up. Molycorp went out of business, Linus managed to survive. So in looking at your project, you need to look very carefully at your assumptions in terms of construction and startup and the associated working capital. Marketing is key, and that drives the pilot plant work, as I've indicated, and also is fundamental to underwriting the funding of the project. So overall, the goal is to have a sustainable project with sound economics. So what does that mean? If we look forward to 2025 and I look at the growth in the market, I think global demand will be about 250 to 300,000 tonnes a year. Rest of world demand will probably be something of the order of 80 to 120,000 tonnes a year. Magnet demand 90 to 120,000 tonnes a year, and the rest of world magnet demand 25 to 40,000 tonnes. China total supply will be 160 to 200,000 tonnes, and maybe less than that. They are now admitting that they have real problems in terms of environmental controls and actually understanding what's happened to those resources which have been mined irresponsibly. So what does that mean? The rest of the world required total supply in 2025 will be somewhere between $75,000 and $125,000, which means between now and then, the rest of the world needs to bring on 40 to 80,000 tonnes of capacity. So that's the opportunity that you have, ladies and gentlemen, to develop a project which can bring somewhere between, well, maybe 20,000 tonnes of REO online to meet that gap.